Hi everyone! Welcome to our learning activity video on solutions to senior high school pre-calculus. For this video, we will have the learning activity sheet for Qtr-2 MELC-1. Or what is MELC? Most Essential Learning Competency number 1 for Qtr-2. For the objective, the learner illustrates the unit circle and the relationship between the linear and angular measures of a central angle. Let us start with the exercises. And in here we have two activities. So let's start with activity number 1. Directions. Solve the following and show your solutions. For letter A, write the following into degrees or convert the given into purely degree unit. For number 1, we have 4 degrees 6 minutes. For the solution, 4 degrees, you isolate the degrees. We have 4 degrees and plus 6 minutes. And we have to eliminate the unit minute by multiplying 1 degree over 60 minutes. We know that 1 degree is equal to 60 minutes. So the purpose here is to transform the 6 minutes into a decimal form in terms of a degree unit. So here, this minute unit and this one down here in the denominator will cancel out. And we can proceed with the multiplication. 6 times 1 degree. So that's 6 degrees all over 60. So that's 1/10 degree. We have it here, 4 degrees plus 1 over 10 degree. Then we copy 4 degrees plus convert this to decimal form. It's 0.10 degree. So the final answer is 4.10 degrees. So for number 2, we have 10 degrees given 20 minutes and 30 seconds. So in this case, we have to isolate the number with degree unit already. So it's done for 10 degrees. But we have to convert 20 minutes to a degree and also 30 seconds to a minute and then finally to a degree unit. But you can also have a shortcut for this as seen in your learning activity sheet. In the second unit here, we convert this first to minutes. And once it is already in minutes, we have to convert to degree. Now, let's discuss this. So, it's 10 degrees plus 20 minutes. And the 20 minutes will be converted to degree. So, this will be multiplied. 20 minutes will be multiplied by 1 degree divided by 60 minutes. Why do we need to multiply with this? Because this is an equivalent or equal to 1. Because 1 degree is equal to 60 minutes. If we convert the 60 minutes to 1 degree, then 1 degree over 1 degree is still 1. So it is just like multiplying 20 minutes by a number 1. So this is the purpose of the transformation into the decimal degree. Okay. The minutes and the minutes here will be cancelled out. So we have 20 times 1 degree all over 60. The 0 here and the 0 will be cancelled out. So 2 times 1 all over 6, that is 26 degrees or 1/3 degree. Plus 30 seconds. We know that in 1 minute, there are 60 seconds. Or this is an equivalent expression. 1 minute over 60 seconds is 1. So, in effect, there is no bearing, but we can transform the 30 seconds into a minute, a fraction of a minute. So, in this case, the second unit here will be cancelled out. So, we have here already the minute, and 30 divided by 60 is 1/2. Our problem in this step is to convert this 1/2 minute into a degree. So let's recall, we have 10 degrees, then 1/3 degree is equal to 0.3333 degrees. Let's have that. Plus, the 1/2 minute will be multiplied by 1 degree divided by 60 minutes. So the minute unit will cancel out. And we have already here 1 degree all over 120. And if you press your calculator, you can have this value 0.00833 degrees. So since all the addends have its units in degrees, we can now add them all. So this given expression, 10 degrees, 20 minutes, 30 seconds is equal to 10.342 degrees. For number 3, we have 7 degrees, 11 minutes, 15 seconds. So 7 degrees is isolated, plus 11 minutes will be converted to degree, multiplied by 1 degree over 60 minutes. The minutes will cancel out. So it's 11 over 60 degrees, plus 15 seconds. We will eliminate the second here by multiplying 1 minute over 60 seconds. The second here will cancel out. So we have 15 over 60, that's 1/4 minute. But take note that this minute will be again multiplied by 1 degree over 60 minutes to eliminate minute unit. So we have here 1/4 times 1 over 60 degrees, or 1 times 1 is 1. 4 times 60 is 240, and the unit is already in degrees. So since all the addends has its degree units, we can add them together. So it is 7.1875 degrees or 7.188 degrees. And we move on to letter B. Translate the following into degree, minutes, and seconds. In this case, we're given the reverse. So it's the reverse process of activity in letter A. So for number 1, we have 10.090 degrees. So we have to convert that. How to do this? We have this step for the solution. Isolate the whole number in degrees, and the 0.090 degrees will be multiplied by 60 minutes over 1 degree. We reverse because we have to eliminate the degree unit here. So in this case, copy 10 degrees plus, by multiplying this using a calculator, the degree will cancel out. Then 0.090 times 60 minutes is 5.4 minutes. Take note, we have the decimal 0.4 minutes. And we need this to convert to a second. So isolating the whole number 10 degrees plus the whole number 5 minutes plus the 0.4 minute will be converted to seconds. And how to convert the 0.4 minute to second? We have to multiply that by 60 seconds all over 1 minute. The purpose is to cancel out the minute unit. And in this case, we have it here, 0.4 times 60 all over 1. That's 24. And the unit is in seconds. So we have 24 seconds. So finally, we just eliminate the plus symbol. So 10.090 degrees is equal to 10 degrees, 5 minutes, and 24 seconds. Moving on to number 2, 20.110 degrees. So isolate the whole number, 20 degrees already. The decimal part, we have 0.110 degree. Eliminate the degree, multiply it by 60 minutes divided by 1 degree. The degree will cancel out, giving us 6 minutes. And, well, actually, the answer here is 6.6 minutes. So we isolate the whole number 6 minutes, and the 0.6 minutes will be converted to seconds by multiplying 60 seconds all over 1 minute. So we have here the minute unit will be eliminated, giving us 36 seconds. How did we get 36 seconds? It's 0.6 times 60 and the second unit. So this is 20 degrees plus 6 minutes plus 36 seconds. And finally, we eliminate the plus sign. So 20.110 degrees is equal to 20 degrees, 6 minutes, and 36 seconds. For number 3, 65.43 degrees is converted as isolating 65 degrees plus 0.43 degrees converted to minutes. We have it here. By multiplying this, it becomes 25.8 minutes. Then, the 0.8 minutes will be converted again to seconds. So, 0.8 minutes times 60 seconds all over 1 minute. The minute will cancel out. Then, 0.8 times 60 is 48 seconds. Therefore, 65.43 degrees is equal to 65 degrees, 25 minutes, 48 seconds. For activity number 2, identify the terminal side of an angle in standard position with the given measure. So we have the given figure here. OB is the initial side. So we're given here number 1 in degree measure, and we have to identify what is the terminal side of an angle in standard position given 90 degrees. So let's have the solution. Okay, we have the solutions for number 1, A up to D. Now let's discuss. For 90 degrees, what is the terminal side? So we have here OB is the initial side and it's positive. So we move counterclockwise. 90 degrees is here. So from this OB initial side, we move to OD, the terminal side. Ray OD is the terminal side. So we have the answer ray OD. We have here the notation ray OD. For letter B, we have negative 30 degrees. So for negative angle, from the initial side OB, we have to move clockwise to have a negative angle. So here, we have negative 30. It's actually ray OA, the terminal side. Why? How do we know that this is just 30 degrees? Well, if we move from the initial side, OB, going clockwise, and we have here, we arrive at terminal side OE, this is all in all 180 degrees. But we have the given that from this OA going to OE is 150 degrees. So that means 180 minus 150 is 30 degrees. So that justifies letter B. For letter C, it's 330 degrees. It's a positive angle, so from ray OB, which is the initial side, we move counterclockwise, and this is 90 degrees plus another 90. We have 180 degrees, and plus another 90, we have here 270 degrees. And if we complete this, we coincide with ray OB again, so one rotation is 360 degrees. But we are required only to have 330 degrees, so less 30. So again, for letter C, we have ray OA as the terminal side. For letter D, it's negative 360 degrees. So what is the terminal side? So from the initial side OB, since it is a negative angle, we have to move clockwise. The movement of the clock in your wristwatch or in your wall clock. So going clockwise, 360 degrees. This is 180 degrees plus another 90, 270 plus another 90. It's 360. It coincides with the initial side. So negative 360 degrees. In this particular figure, the terminal side is ray OB. This completes our discussion in this activity. We move on to the radian measure. We have here the solution. Let me discuss one by one. We start with pi over 2 radian. Where is the terminal side of the pi over 2 radian? Earlier, we have the unit of measure in degree, but right now we have radian measures. Pi over 2 is actually equivalent to 90 degrees. Meaning, from OB going to OA is pi. We traveled pi, and half of it is pi over 2. So ray OD is the terminal side of pi over 2 radian. For letter B, negative pi over 6 radian. So since it's negative, we move it here. And we know that 30 degrees, this is 30 degrees here, and 30 degrees is equivalent to pi over 6. The only difference here is that this is negative 30, and negative 30 is actually equal to negative pi over 6 radian. So OA is the terminal side. For letter C, negative 11 pi over 6. So it's negative, so we have to move clockwise again. This is 6 pi over 6 that we have plus 5 pi over 6, this one here. This is the terminal side OC. So if we have it in degrees, it's actually negative 330 degrees, and that is equivalent to negative 11 pi over 6. So the terminal side of negative 11 pi over 6 radian is ray OC. For letter D, is it ray OE for negative pi? Let's start here. Yes, it is ray OE. So this concludes the discussion for this activity. So for the reflection, we have the guide question here. What knowledge, skills, and or values have you learned from this activity which you think you can use in your daily life or future endeavors? Well, let me remind you that this guide questions is a personal or subjective level of answering the question. And you have to answer this with all honesty so that your teacher or facilitator will know that in effect that learning activity sheet that you have in your hands right now helped you in some way, because without the presence of a face-to-face encounter with your teachers. In my case, I will answer in a personal level. You have there in your learning activity sheets, accompanying the learning activity sheets are the answer key, and you are provided with that. And sometimes, if I were a student, I would be also tempted to copy all the answers so that I can have a score, or my score is higher to increase the chance of passing the subject. But going through what are the knowledge, skills, and values. The values that I learned from this activity is the honesty. Honesty is very important. You have to develop honesty. You have to be honest. You have the answer key there, but make sure that you will learn how to answer or to come up with the answer similar or the same with the answer key in such a way that you have to study the learning activity sheets. Another one is for accuracy. You know, in pre-calculus and in general mathematics in general, you have to have the exact answer. You need to be accurate. So honesty and accuracy is the values that I learned in this activity, which I could use in my daily life or future careers or future endeavors. So these are the references for the learners. So we have it here, teaching guide on pre-calculus for senior high school. Then we have here, it's in your learning activity sheet. So this ends our learning activity video, and please like and share and also subscribe to this channel so that you will be updated with more learning activity videos related to pre-calculus. This is Teacher Marichu saying always stay happy, healthy, and safe. God bless us.